Hitting the right colors in print production. In this webinar, we are covering a typical situation in a mixed print production. Reprints should look the same to the original print run, only that the original prints have been produced in offset and the reprints should be done on a digital printer. How a close match can be achieved using the color management tools from ColorLogic will be shown to you by me, Dietmar Fuchs, Product Manager from ColorLogic. We will be using CoPrA to build the required DeviceLink profile and the Color Server ZePrA to convert the PDF file. Before we are doing this task in reality, I would like to start with an overview about what the issues are we need to take into account. There are various differences between offset and digital printing. The inks are different between offset and inkjets or toner-based digital printing. The tone value increase is different. The gamut might be smaller, larger, or similar. In any case, the colors will look different without using proper color management. The next two slides illustrate this. In most cases, the gamuts, here are two CMYK gamuts, offset and a smaller digital one, will be different between offset and digital printing. And some colors might be out of gamut, as indicated with the grayed out yellowish and orangish colors here. Quite often, the digital printer's gamut is larger than the offset one. The calibration of offset and digital printing machines is different and results in completely different TVI curves. Without taking these differences into account and not using color management will result in a bad match. So what do we need to build a workflow that does the trick to get as good as possible visual match between the original offset print and the reprint on a digital printer? You need to make sure that printer profiles are of good quality. The use of DeviceLink profiles is necessary as they allow for important print-related extras, such as the selection of the right rendering intents for a perfect match and the use of color exception rules to make sure that some important colors, such as black, gray, primaries, etc., are treated separately. For print production, the use of PDF as your print-ready format is more than just suggested. PDF contains images and vectors, and it's important that both are converted properly. The use of a dedicated color server for conversion of PDF files is therefore recommended, and I will show you in the live presentation that follows now why that is the case. As an example, I have here a calendar with birds. In this case, these are cranes, a German calendar that was printed in offset on coated paper. And the press was calibrated to match the standard profile ISO-coded version 2. And now the reprints are going to be produced on an HP Indigo digital printer with a slightly different coated paper. In my example, I have already created the profile for that HP digital printer, and I will use that profile as well in the conversion later on to show you why a printer profile itself does not do the trick, but we need to create a DeviceLink profile to get the closest match. And we need those printer profiles that we've created up front with CoPrA. And this is CoPrA, the color management profiling tool from ColorLogic. And now I will be using the DeviceLink tool inside CoPrA to create the desired DeviceLink profile. To do so, I click on the DeviceLink icon. I select the source profile, which in our case was the ISO-coated profile. So I will select the ISO-coated profile here. As a target profile, I will select with right-click the shortly before created HP Indigo profile here. So the previously created profiles are listed here directly so that the selection is easier. I can select this profile here. I can select a setting from the default settings here to targeted settings, and you'll find that there is already a preset that we have created for digital printing that allows for a close match, and I will select that. So once that is selected, I can go to customize and see what the settings are. So the important setting here, or the multiple parts that are important here, is first of all the rendering. there is a chooser to select the rendering methods. There are a few options here. We select the close match option. If you go to custom, you will see that there are a lot of different rendering intents, and it's important to select the right rendering intent for your task. In our case, we want to make a close match, and therefore the selection of this option here, close match, which will select the minimum white compression and the minimum compression here in a mixed environment, will be used. So the next thing we want to look into are the exceptions. And typically CoPrA calculates the exceptions automatically depending on the source and the target profile. And what we can see here is that gray colors and 100% black will be kept pure, as well are the primary colors and the secondaries. And CoPrA will make sure as well that we get high saturated RGB values too. So that's enabled with the max RGB setting. So those settings are automatically calculated and will be applied automatically from CoPrA. You can override those settings by clicking to custom, and then you can enable or disable additional options here. But we will use the automatic here, because it gives us already the right settings. On the color generation tab, we can fine-tune our separation settings. For example, here in digital printing, we typically want to have a strong black. Therefore, the GCR amount is on a very high level, giving us more stability in print by using more black and less CMY. We want to use that as well. But of course, you can change that to your liking, depending on what you want to achieve, or if your black start should be a little later introduced into the separation. But that's all customizable. For the black point is typically a very important setting on the profile, as we have created already the correct black point for this target printer profile in CoPrA before. We can simply select the target profile setting here from the option. There are several options here, like using the darkest or a neutral black point, or in the automatic option that looks into the desired tag as well. And we can see already here which will be the LAB values that the DeviceLink will create, and the automatic the tag that it automatically figures out, which is 330% in this case. So all we need to do now is to give that profile a name, a speaking name that we can find later on faster. So I'll just shorten this to folder 39, to HP 25,000. This is CMYK profile, and it is using a tag of 330. So, and maybe we just add the close match here as well. After setting up the name, all I need to do is click on Save to create the DeviceLink profile. And now, as a next step, I would like to apply the printer profile and the DeviceLink profile. And to do that, first of all, from this calendar, I selected the last page, which was this page 14 with all the images from the calendar, and extracted that as an image in Photoshop. And we want to use that image for the conversion and to check how the original looks like, which is here in this case, the ISO-coded variant, and how it looks like if we do the conversion. I could apply the conversion here in Photoshop as well, but I will use CoPrA, as it has a very nice functionality for the applying of profiles. For that, I will use the image conversion feature here. In the image conversion feature, I can select my source file, which is the image. CoPrA supports image files like TIFF and PSD files. So this is my image file here. The source and the target profiles are shown directly. In our case here, the source is the ISO-coded profile, and the target profile will be my HP profile. And of course, I don't want to use absolute colorimetric here, but the perceptual conversion. And it will do the conversion as I would do in Photoshop, selecting source profile, ISO-coded, and the target profile, my HP profile, and I would do the conversion. And instead of just converting that file, I used the layer functionality in the image conversion tool and it will create a PSD file with layers. And what that does, I will show you very soon. So what I want to do is I add this conversion as a separate layer to this file, and I'd simply click on the Add Layer button here. And as I explained to you already, that the use of a printer profile itself will already give you a certain quality, which might be okay already, but to really get the closest match, we need our DeviceLink profile. And in that case, I want to select here with right-click the DeviceLink profile we have previously created. So again, with right-click on this little button here, we'll see all the profiles that I've previously created, and the last one is on top. So that's the one we just created. And I select that profile. And as you can see, the target profile here is disabled because it's a DeviceLink. A DeviceLink is a combination of source and target profile, so there's nothing else to select. And what I want to do is I will simply add it to my layered file by clicking on the Add Layer file. So my PSD document now has 2 layers, and I will simply select that document in Photoshop now. So we're going to Photoshop, and what we are seeing now here is a layer, or the layers panel. We can see 2 conversions. On top, that's the DeviceLink conversion, and below that's the normal ICC conversion using perceptual rendering intent. So all we want to do now is to check how the conversion performs in regards to the original iso-coded. So we're switching to the original iso-coded image here. And for a true color view, we need to go to View, Proof Setup, and we need to select our setting correctly, which is in our case here, the iso-coded profile. We want to use the paper simulation. So this gives us a true color view of how the print will actually look like. So we need to enable that. And on our converted document, we need to do the same thing. Only on the proof setup, we have to select our target profile, which is our HP Indigo profile, which is automatically embedded in the document from the image conversion of CoPrA. So again, we will select paper simulation here. And now if we switch between the original iso-coded variant, printed and offset, and our digital printed variant, we see, of course, the slightly difference in the tone values here, in the paper tint. So this one has an LIB value, as you can see on the right side, of 94 and -4, something like that. And the iso-coded variant has 95 and -2, so it's a little bit lighter and a little bit less blue than the variant here that we are reprinting on this paper here on the HP Digital. And we can see as well slightly color differences. They are not huge, but they are there. And if the goal is to get a perfect match, now I do the trick. I select the DeviceLink conversion. And you see there is already a slight difference between the printer profile conversion and the DeviceLink profile. And the DeviceLink profile now with a layer is on top, so we are seeing that. And if I switch back to the iso-coded variant and this one, we can see only very, very small differences between those 2 conversions. So we get a very close match to the original, which is much better than just using the printer profile in our case. In addition, there are some additional benefits using the DeviceLink profile, and I will show you that in the next step, because obviously this is just one image we have converted, but the original is a PDF document with images, with vectors. There are text elements, and we want to make sure that the text elements are converted properly too. So we don't want that text is converted to 4 colors, which would be the case with a printer profile. For the conversion of entire PDF documents, as in our case here, the calendar has multiple pages with vectors and images, we are using the Color Server ZePrA. And to do so, we are setting up a workflow. We click on the Home button and we use the Auto Setup tool. Typically, there are multiple settings that need to be correctly applied. And the auto setup makes it very easy to set up. And by doing that, we can select from a list of 8 typical workflows. And the most typical one is on top, which is the normalize and convert colors to new output condition. And indeed, in our case, we want to convert from isocoated to our HP Indigo, so we select the first auto setup mode here. With continue, we can either select an existing DeviceLink profile or use SmartLink. SmartLink will create device links on the fly, but we have already created our DeviceLink profiles before with CoPrA, so we want to use that. Click again on continue. And again here, that's with all our ColorLogic applications, instead of selecting the profile manually here from a list or by typing in a name, you can right click and the last created DeviceLink profile will be selected. That's the one we previously created with CoPrA. So we select that. And the next step is that from the profile name, a Q name will be generated, which we just take in this case, as it is already quite speaking. And we click OK. And now we see the configuration with all the settings and the queues and the folders, hot folders are created. And if there are no specific additional settings that we might need, for example, like flattening or converting of spot colors, then this configuration is already ready to go. In our case, the calendar is not that complex. There are no large transparencies here. There are no spot colors, just images and some vector elements to be converted. So we can take that configuration as is. So what we want to do is we can either with right click here on a configuration, add a file to a queue and start processing, or we can open the folders. So I will select that option here, and you'll see this will be the folder structure. So there's several folders here, and the input is already highlighted. That's the folder where you would place in your PDF document. So that's my PDF document. I will simply place it in here, and what you would see is ZePrA recognize this file right away and will start processing and will do the conversion of the entire PDF document. So that's quite fast. ZePrA is very fast in these things. And once this is done, the original file is located in the done folder, and in the output folder, you will see the converted file. And we will have a look in Acrobat. So this is my converted file. I will go to page 14 as well here, so that we can see the original isocoded variant, and that's the converted variant. And the nice thing here is when we have a look, for example, into our black text here, I will go to the output preview, and if I select here a black text, you'll see it is still 100% black. And maybe we'll find other things here. For example, here, that's a gray. The original gray has a certain CMYK value, black value, gray value. In this case, again, the gray is maintained as is, 42%, where in the original one, it might be a different value. Just for your curiosity, it was 30%. Due to the tone value increase, ZePrA will make sure, and the DeviceLink will make sure, that the gray values will change, but it will give you the right color appearance to the original one, keeping the constraint into account that it should use only black color. And that's very important for print production. So our grays stay gray, black is 100% black, and if there are other color objects like using primary colors or secondary colors, they would be retained as well as pure colors, so that our print production would be pure and has a good color rendering at the end. And that's the trick. Basically, we need to use DeviceLink profiles with the right rendering intents, and we need to use a color server to convert not only the images, but as well the vector elements, to make sure that everything is converted properly for the HP Indigo. And now I can simply use that PDF document, converted document, and print it without color management on my HP Indigo printer to get a perfect match to my offset print, and I have a perfect hybrid print production that matches offset and digital printing, thanks to the ColorLogic tools.